Okay, now we're going to close with a fairly detailed example. And in this episode, I am going to show you how I want you to break down functions when you're thinking about it. It may not be necessary for visualization of the transformations at this point, but this sort of thinking is going to help you as we go along through the semester, because right now we are making transformations of our basic key functions, but we are going to be continuing to transform functions using the methods that we have here all through the semester. So, the example I would like to use here is y is equal to 2 times x minus 3 squared plus 5. So, let's think about this. I can see several different things happening. We're multiplying by 2. We are subtracting 3 inside the parentheses, and we are adding 5. Now, it's important here to work our way from the inside out. We are going to stick with parentheses, multiplication and division, and addition and subtraction in that order, starting with stuff inside close to the parentheses. Now, I left off exponentiation for a reason that you're about to see. Step 0, which comes even before step 1, is always going to be a key function. Now, we know from looking at this that it's a quadratic. It has this exponent of 2, and so it's going to be a parabola. And the point here is that the key function that gives this graph its essential shape is y is equal to x squared. So, the key function is for the essential shape. We don't want to start inside the parens with just x minus 3 because that's a line. And when we finish with this thing, it's not going to look anything like a line. We want to start with something that looks similar to what we know our end product is. Okay, so here we have y equal to x squared, and I'm going to make a table of values. So this is just sort of our canonical parabola. I'm picking values that I like. They could be any values, but I want values that show me interesting features of the parabola, like its vertex, and enough to show something about how it grows. Okay, so here's my first step in graphing it. Okay, next step, I'm working my way from the inside out. So inside, in this case, means inside the parentheses, close to x. The thing closest to x is not this multiplying by 2, but rather what's right there in the parentheses with it. So that means that my next step is y is equal to x minus 3 squared. Okay, now this is inside the parens, so it's a change to the x values. But there's no change as far as the y values are concerned. So I can copy these y values Okay, what I've done here is I copied the y values that I had before, and now I know that my x values are going to move 3 units to the right, so I'll take the x's that I had before, which were -2, -1, 0, and so on, and add 3 to each one of them. So now I have 1, 2, 3, 4, 5. And the effect on the graph is I move to the right, and so now my vertex, rather than being at 0, is at 3. But my y values haven't changed. And I notice now I have an error in one of my y values. This is supposed to be a 4. I'm sure you noticed that already. Okay. So, the next thing, moving from the inside out away from the x, is, well, I have a choice, the multiply by 2 or the add 5, but remember, multiplication comes before addition. So I'm going to do the multiply by 2 first. Okay, so that will be step 2. And so I have y is equal to 2 times x minus 3 squared. I have now a change only to the y values. Because why? Because it's outside the parens. There. Okay, so my x values are just the same. 1, 2, 3, 4, 5. And my y values are now going to be multiplied by 2. Okay, so the 4 becomes an 8, the 2 becomes a 2. 3 stays at 0. Okay, now let's update our drawing. So we started, this is just intended to be a quick and dirty sketch at this point. We started here, we moved here, and then we stretch all of that up by a factor of 2. Okay. And then, let's see, that was step 2. Multiplying by 2 was the second operation changing from our key graph. Okay, and now step 3, which is also the last. Step 3 is the addition. So 2 times x minus 3 squared plus 5. This is also outside the parentheses, so it's going to change only y values. And what are we doing? We are adding 5 to each of those. So let's copy the x values with no change and add 5 to each y value that we have here. Okay. And those are the coordinates for our finished graph. And so the last one we want to make, we're going to do more carefully. Okay, and we have 1, 2, 3, 4, 5. That 3 is there in the middle, and 1 to 13. Okay, when you're drawing something like this, when you know that it goes on forever, be sure to draw your arrowheads there, and we want to have our arrowheads here too. Now, let's look at the same transformations in Desmos. I like to draw everything first. This is to check my own abilities. I gotta use it or lose it, really. And then I want to go to a calculator or an on-screen grapher and verify what I've done. So let's do that. Okay. In order to check my understanding, I'm going to do this in Desmos in the same order that I did it by hand. So my first transformation is the one closest to the x, and that's the subtract 3 in parens. And so this moves everything 3 units to the right. Ooh, not that much. Okay, that looks good. Next, we multiply all of the y values by 2. Stretching them up. And then we add 5 to all of the y values. There we go. Pretty dramatic, huh? Okay then, that's the end of this presentation.